record this computer. All right, so everybody online can hear me and see my screen. Everybody here can hear me and see my screen. All right, let's get Keynote open here. Getting ready to talk about stacks and procedures, and then iOS and Android stuff. Yeah, I think this is what we talked about conditionals last time. Load, store multiple values. Try to think back to last Monday rather. This is like our last slide that we dealt with? Okay. All right, so let's get going. Oh, first of all, stupid thing for the day. So this is not going to be related to the slide. I'm going to be taking it off in a second. This is just more of a weekend brain fart. So when something says available March, that doesn't mean March 1st. The exclamation point doesn't mean 1. I've been reading it like that for weeks. I've been reading it something like this, that these packs for this online game I play, I thought were going to be available to open today, being March 1st. But no, it's just sometime in March. But that's okay. But I've been planning kind of days around this idea, this unveiling of these 145 packs of cards.
Have they actually put a date on it?
No, just available in March.
Till now, they say
Even right now, yeah. So I mean, there's rumors online that maybe March 22nd or March 23rd is when the expansion drops. But whatever. I mean, it's fine, because that means that for the next, let's say, 22 days, I'm leveling up with the same cards that I'm already used to, which takes a little bit of the excitement out maybe, but also puts a little bit more cruise control on. And for those of you online who don't know what I'm talking about, it's probably for the best. I kind of play this online game professionally, and I'm in tournaments and stuff now. It's I told you it might be in the Olympics, right? So I potentially in 2 years could be an Olympian. Wouldn't that be hilarious? All right. So let's get into some stuff now. All right, so we were talking about registers in general last time. I think before that you had a homework assignment. I'm just going to bounce back just a little bit. So you were kind of writing some assembly code that moves around some variables and things like that, just kind of getting used to the code. We're not going to write anything crazy in here in assembly. We really want to kind of understand the current state of, really we're talking about the current state of processor architecture, but I want to focus on, when we say mobile today, we really think iOS and Android. We've talked about that several different times already. So I want to focus on how does this stuff translate onto iOS and Android, and if we were going to use that, how does it work, that kind of stuff. Okay, so with that in mind, I'm just going to bounce forward to where we were. So last time, and this is review a little bit for you, but also for me, since we missed last Wednesday, but we talked about magnitude versus bit space. I think the question came up in class, what if we have a relatively small value and we want to store it in one of our registers? With CPUs with the registers that are on CPUs, we do kind of have this throwback, and we'll see this in a few minutes. I kind of list the use of some of these registers. We do have this throwback to some of the early days in computer programming where we kind of had to care about memory. It really doesn't feel as bad working directly with the processor as it did working indirectly through a high-level language back then. But you still got to think about it a little bit. But the question last time was asked kind of generically, like, oh, well, I can represent the number 3 in 2 bits. Well, if I have 16 bits to work with, I might as well use the other bits for other things. Keep in mind, we do need to be somewhat consistent, right? If you're passing something, if you're loading a value into a register or a series of values into a register, and then you're calling some function, which we'll talk about today, that function needs to know how to decode that register. If you put 4 values in there, 4-bit values, let's say, it needs to know that, oh, okay, I need to extract 4-bit values from this guy. It's not just one gigantic 16-bit value. Does that make sense? So somewhere in there, we need to make sure we're speaking the same language on both sides. Just because I can put more stuff in the box doesn't mean the guy who's going to be using the stuff that's in the box knows there's 4 things in there instead of 1 thing in there. Okay, so we can be a little bit sneaky, but at the same time, we want logic has to play into there at some point. So last time we talked about magnitude versus bit space and how we can use bit shifts and ands and ors to kind of extract individual values out of a register. If we put 4 values in a register, we can use bit shifts to, let's say it's a 16-bit register and we put 4-bit values in there. We can keep shifting by 4 to the right and then anding everything except for the right 4 bits to get us just the right 4 bits and then read the value from the whole register. So we can play that game and get multiple things hidden inside of a register if we want. We talked about this difference between the program counter on Intel versus the ARM architecture, where program counter for ARM points to the next instruction, where the program counter for Intel points to the very next instruction that the CPU is going to eat. Whereas the program counter for ARM, as well as I think we mentioned thumb at some point in here. Thumb is like the low-powered ARM. Think of it as like ARM mini, but get it? ARM, thumb, smaller body part. It's a thing. But the logic is equivalent for both of them. Just the size of an ARM instruction versus the size of a thumb instruction is half the size of a ARM instruction, which means there's less total instructions that are possible. But the idea is that thumb probably has less registers, smaller registers, because the goal is probably a smaller device or a less powerful device or whatever. So maybe they're paying a little bit more attention to battery life on that device. Kind of makes some sense. So as we think about general purpose mobile computing, like our smartphones, which these things aren't phones anymore, right? We kind of reference that. I mean, these are powerful computers at this point. I mean, we're not far off from, in fact, it already exists, right? I know with Samsung, they have a thing called DeX, D-E-X, where you can effectively, now you can do it with any Windows machine, but otherwise they had like a kind of a tablet-y thing where you just dock your phone and that becomes the laptop power behind it. Okay, and you're getting something that's, we'll call it at least as powerful as a mid-range, well, probably a higher range Chromebook, something like that. Okay, but for us, I mean, we're not really worried about those. Certainly, they're not popular yet, right? What we see as being popular outside of like a laptop are the tablets, the iPads, the less so the Android tablets, but certainly we see iPads all over the place, right? All right. And now you're also seeing the Windows Surface books, which kind of are like that dual, hey, I can be a tablet, but I can also be I wouldn't call it a laptop because it's a little bit rough to balance on your knees, okay, but certainly a portable Windows machine. That doesn't necessarily equal low power. I mean, I have one in my office right now. I used to have a bigger one, but I have one in my office right now that's a small Windows Surface, which is it a 7-inch screen, maybe something like that? Has a little keyboard and stuff. So I mean, is that what you want to use as your day-to-day Windows machine? Probably not. But it does play the card game. It does play Hearthstone just fine. But in any case, the idea of mobile computing is constantly evolving, and it's clearly the direction we're going. Right? When I travel, I might bring this big laptop if I'm going to write some software wherever I'm going, which I think I've told you that I do that on cruise ships is like my hobby. I try to write something that pays for the cruise while I'm on the cruise. Yeah, it's a whatever. But so I might bring my bigger laptop for that. But if I'm just looking for the thing to check my email daily, play my game, whatever it is, I'm going to bring either, my iPad, or I'm going to bring that smaller Windows Surface device if I want more of a normal PC type of experience. And we're even seeing now, for a while now, with Apple and the iPad, where they're going to their pro versions of these things with the idea of kind of closing that gap between who needs a iPad versus who needs a laptop. Right? That makes sense. I mean, as computer scientists, we probably still need the laptop or a desktop computer. Just the flexibility of applications just isn't quite there yet on the tablet. But we certainly don't have as much confidence today as we did 5 years ago that our idea of the mobile desktop experience is kind of becoming less and less of a thing. Even newer versions of the Mac OS have moved towards this idea of being now, I think we mentioned in here, the M1 processor in the latest 13-inch MacBook Pro, and also the MacBook Airs. Well, so that guy is the same architecture. It's an ARM-based architecture, just like the iPad is. And now the thing is architecturally compatible with the iPad. So their laptops are moving closer to the iPads. The iPads are moving closer to the laptops. That's going to become a very, very, very blurry line very soon, right? Because now, if they have a version of their operating system that runs natively on the M1 chip, and the M1 chip is architecturally compatible with the whatever the current one is, A4 chip, whatever the current iPad A chip is, A14. That can't be right. How did I miss it? How did I miss 10 iterations of the chip? That can't be right. It's A14 is the current version. And did it just go A1, A2, A3, or did they start doing stupid jumps? Did they jump to like A10, like right off the bat? Like they started off with the A series and they went to A10. They haven't been using it long enough to be A14.
Okay, it was in 2019 it was A12, so most probably it would be A14. In 2019 it was A12? Yeah.
Okay, so that makes sense. A13. When did the A chip first come out? How fast is time traveling? It feels like they just started making their own architecture 6 years ago, maybe? Yeah. So if it's been 6 years since they've been making their own chips, how are we at A14? There's some naming convention stuff in there. There's some jumps.
Well, I can see they started by A4.
So the first one was A4.
Yeah.
And probably on iPad.
I'm making sure it's not saying that it's. I'm just reviewing the history of the.
Okay.
So it was A4, A5, A5X, A6, A6X, or actually the X's are in the same year. So A6, A7 till A14.
So A4, A5, A6, A7.
4, 5, 6, 7, 8, 9, 10, 11, 12, 14.
Okay, so they went from 12 to 14, but from A4 to A12 was straight. So it's more than 6 years. Or were these 2 per year where they had like the A4 chip, and then when they released the iPad, they had the A5, and that was like 6 months later. Maybe something like that to compress it into fewer years. Okay, well, whatever. So the A14 chip now, even though it's a different chip name than the general purpose processor that's in the new MacBook Pro, the M1, there's a level of compatibility. They're both ARM-based processors, which effectively means that Apple has, I guess I'm not necessarily positive if they've already done this. I presume they have, but that they've ported their operating system, OS X, over to native ARM code for the M1. And then the operating system, along with the architecture itself, does the mapping to make sure your Intel-based things still work. It's possible that Apple has not ported its OS over to M1 native, but I would be surprised if they haven't done that. Doesn't matter, because even if they left it as Intel, the architecture will do the mapping. But I think it's pretty safe to bet that Apple has ported their own stuff to run natively on the M1, and it's the other people's stuff that's going to require that translation for right now. But in any case, we clearly see this big company that does move the needle when it comes to innovation, whether you like them or not. We see them throwing their everything into, all their hats into the basket that is ARM based. All right, and we're probably going to see that continue on the Windows side. There's already a version of Windows, well, it started off as Windows CE that ran natively on ARM. So we're already going in that direction there. So it seems like we're moving away from Intel-based processors and towards ARM-based processors. Not that Intel's going to completely go away, but realistically, Intel will probably ride the desktop and current laptop market to the ground. And then we might see 2 lines in the sand, right? You're going to say maybe Intel flip over and start making ARM architecture, which probably wouldn't be in their best interest. They would have to probably create a competitor to ARM, which is looking at lower powered chips. They've already tried to do that with some of their single core and their lower power Intel chips, and they haven't competed very well. Otherwise, we'd see smartphones with those in there. We don't feel bad for Intel. They run a graphics card company too, so.
I don't see that Intel will drive anything to the ground yet. I mean, that driving the laptops and computers to the ground will take at least 10 years from my perspective.
So you think that our laptops and our desktops are still going to be running our Intel architecture chips for 10 years from right now?
What I'm saying is not for us. What I'm saying is the market will probably be different in 10 years. ARM will probably be our used architecture. Intel will be for the powerful market, industry-based market.
Okay. So maybe, yeah, I get what you're saying. So you're saying that Intel no longer becomes, this is speculation. So you're saying within 10 years, maybe Intel is no longer a consumer-based chip, even for the power user consumer, but they'll still be maybe a server-based chip or an enterprise type thing for whatever, where the idea of mobile isn't really a thing. Pure power is the thing, and Intel will continue to evolve their product and maybe start evolving away from consumer chips where they have to hit price points and towards highest end performance chips where enterprises will spend a bunch of money on something. As long as it's delivering the power that they want. So maybe Intel becomes the power of the cloud, something like that. If we take this one step forward from there, if we think about, when we talk about the cloud, so we're really talking about storing stuff outside of our computer. And it's not just storage, it's also leveraging the computing power of things outside of a computer. Now that's going to become pretty, I mean, if we, I'm going to throw something in here because I think it's actually pretty important to what we're talking about here. So when we talk about cloud computing, we're talking about storage outside of the device. We're also talking about compute power outside of the device. Both of those things, right? Storage outside the device means we need less, I'm going to put that in double quotes, storage on the device. Compute power outside of the device means we need less processing power on the device. Both of these things together means we can either have smaller devices or better battery life. Both are things that we view as being important for mobile computing, right? So one thing you're speculating here is that this idea of cloud computing, we can say this might be where Intel lives in 10 years, powering the idea of cloud computing, because this is something that you have many individual users. Every one of us who's carrying a mobile device is all going to be hitting the same, well, maybe not a single computer, but a cluster of powerful computers that don't care about battery life. They don't care about all these other things. They're plugged into a wall somewhere. 10 years, maybe they're running off atomic energy or whatever. Doesn't matter, right? The idea is it's on the high end power, paying no attention or paying little attention to resource consumption in terms of electricity. All right, so now we can have longer life mobile devices. We can have we can have smaller devices, longer life devices, or even more powerful. Where there is a powerful mobile chip, local, along with a mechanism for offloading some compute to the cloud. So now you have options, right? Something that you need right now in real time, maybe that's something that's done locally. Something that is kind of being, processed for the future. Now you start thinking about maybe using your smartphone or your mobile ARM-based device for like rendering video or rendering graphics or something like that. This is especially true as our, so we can throw another thing. This is especially true as our internet connections get faster and faster, 5G and beyond, whatever that ends up meaning, right? Okay, because effectively our internet connection we'll say the role of the internet connection our internet connection is the bus that connects our mobile device to the storage and compute power of the cloud. So just as system memory has a bus that runs between it and the CPU, and another that runs between it and the hard drive locally on the device. Our mobile devices have a means to store stuff in the cloud and ask the cloud to compute stuff for us, but access to that stuff, maybe a photo, so we could say like photos, or the result of some computation, will be constrained by the speed of the communication bus, i.e. internet speed. That makes sense? So if we fast forward in 10 years, do you think we'll have faster internet speeds than we have today? Seems like we're going in that direction, right? At some point, we're probably going to hit something that's going to be similar to what we did with processors, right? Where our processors stop getting faster. You know, we start hitting the limitation of like radio waves and stuff like that, right? Because right now, all of our mobile computing stuff is all based still on various spectrums of radio waves, right? And trying to maximize how fast we can transfer stuff through the air without cooking people, right? Well, I mean, you know, with 5G, you know, one of the things they talked about is, you know, should you hold it near your ear and stuff like that. So, you know, these are things to consider as we continue to push the envelope for how do we transmit stuff. We do have to consider the radiation that comes from such efforts, and whether or not we start having diminishing returns in terms of culling the population. I guess we'll have to see. But you know, these are all kind of interesting concepts. What if you roll forward? Chances are we're going to have faster internet in 10 years, which then makes the idea of cloud computing more viable, because storing stuff outside the device and being able to have relatively real-time access to it through a very fast communication channel seems like it would be reasonable. Also, offloading compute stuff, if we can toss a job up to the cloud and get the result in a time that isn't unreasonably slow compared to the amount of time it takes us to move something from local system memory to the CPU and have it computed, for example. It probably is not going to get to the point where it's as fast as that, but we might get to the point where it's fast enough for many tasks for the end user to not notice that some of the stuff that's running in the background is actually offloading its compute to the cloud rather than using local system resources. And then you have that question of, well, if I'm using local system resources like the CPU versus using the radio for sending it to the cloud, am I losing or gaining battery life? And is that worth it? So we're seeing all these trade-offs that become part of that, right? And we're just guessing at this point which direction it ends up going. Go ahead.
Yeah, one final point about these two slides, and then we can move forward
Mhm.
to the lecture, is that we're partially there. We're not about these two slides,
Mhm.
internet connection and using cloud resources. With, for example, the cloud gaming platforms like Nvidia and
Yep.
Stadia. I can use my phone to play games that are played from servers on
Yeah, that would usually be on your PC or something like that. Yeah.
Assuming that this is on the other side, it's Intel, so it's basically the same
Yep.
thing.
So yeah, so your point is that we're already seeing the evidence that what we're talking about here is likely to be true. It's already becoming true today, and it seems like, to me at least, that it's only going to keep getting better. So the question then ends up being, will it ever become good enough to be a viable solution? Because I mean, like you mentioned, Stadia. So being able to play Xbox games and PC games, things like that, on a remote device like your phone. So yes, it's possible today. It's decent, right? But that's not the best way to consume your video games. Is you're better off sitting in front of your monitor with the keyboard and mouse versus on your cell phone trying to play something that wasn't really designed for a screen that small. Proof of concept, technically possible, may be fine for some genres of games, but certainly not going to take over the idea of console or PC gaming anytime soon, right? But to your point, as our internet connections keep getting faster and faster and faster, and our mobile devices, I mean, now I have an Android tablet that I can wear. I put it over my head. There's like a strap, so I can walk around the house with this thing just kind of like laying on my belly, but I can see it. So it's like hands-free use of a tablet. Okay, and I'm wandering around the house with this thing. So I mean, once you start getting screens that big hanging off your body as if it's an appendage, maybe this idea of gaming remotely, it becomes a real thing. And even recently, what you and Blade were working on. So across the hall here, and maybe we'll go and demo it one of these days. We have this really cool VR chair. Okay, so this is this chair you sit in, and it has some rumbling and stuff like that, but the chair moves, so it's supposed to increase your immersion into these games. Well, so that's one device. Now, this chair was originally designed for you to connect a PC to it, either using the original HTC Vive headset or the original Oculus Quest headset. Well, we've moved past those two headsets in terms of the evolution of computing for VR, at least. Okay, so now we look at, well, what are alternatives? Well, you can hook any kind of headset to this thing that you want, as long as you can somehow get the computer by it. So you can now strap a laptop to this thing that has a high power GPU in it, and now you can hook up any VR headset that would run off that laptop. But in my view, the best VR headsets today across the board, if I was going to pick one, if you were going to get into VR and you were going to pick one headset today, it's the Oculus Quest 2. Now, if the best PC VR is the Valve Index, which it is, it's not cheap and it's hard to get, but if that's the best PC VR, if that's a 10, the Oculus Quest 2, which can play PC games using this link cable, is maybe an 8.5. It's pretty good, right? But so we'll say the original killer application for the Oculus Quest 2 is it's completely self-contained mobile VR. It has its own app store, its own games. You don't have to plug a phone into it or anything. It has all the internals. It has 2 hand controls, 6 degrees of freedom, the whole VR experience, but on the mobile side. So the games where you don't quite have the horsepower behind the scenes, kind of like we're talking about here, right? So now you have this device that has, that it really shines in being able to take your VR headset wherever you want. It's running off a mobile, it's running off a battery, just like these other devices we're talking about. It's a mobile device. And you can play a whole VR library with an operating system built specifically for consumption in VR. And then you're going to say, well, there's some of the games I really want to play that are only available on PC VR. Fine, you can take the same device and you can use their link cable. You can hook it to your PC and you can play PC VR games on it. Okay, so now I get the best of both worlds, but I do give up mobile computing. I give up wire-free VR by hooking it to my computer to do that. Well, then we look at, there's kind of a hack. There's a app on Oculus Quest 2 called Virtual PC, which is a $15 app. And the concept behind it is it allows you to you run like a server on your PC, and it allows you to run your PC from your VR. Okay, so I actually want to look at, because I wasn't even going in this direction, but this is a great example of cloud computing, mobile stuff. So we talk about mobile VR. Actually, let's just talk about virtual reality. Which I think we can also say in the next 10 years, is going to probably become more and more of a thing. Okay, especially with COVID, right? You know, VR. I mean, VR in the early days was really, really, really cool, but the only people who could do anything with VR were the PC gamers. They were the ones who had the graphics cards that can drive it, and they already had the $5,000-6,000 computers that could drive it. And what did those consumers want as their things to use VR for? They wanted video games, right? Video games are cool for VR, but it's not the killer application for VR, right? Just like, you know, we have our makerspace here on campus with a zillion 3D printers. When somebody gets a 3D printer, the first thing they do is they print out Baby Yoda and Spider-Man and, you know, all those things. That's not the killer app for a 3D printer, but you can do it and it's cool initially. The killer app then is once you move past that is, oh, I can invent my own things, right? My own widgets that allow me to accomplish something. You know, it might be something, you know, benign, but like a good example of a real use of this is, and I'll use a more recent one. You've heard me maybe say some other ones before. So about, I don't know, 6 months ago or so, getting out of my shower, you know, you got that little towel rack thing that's like on the door. And, you know, this door is some old custom door that was made specifically for, you know, the width of my shower, which is some non-standard width. Okay. Well, I removed my towel from said towel rack with a certain gusto that ripped it off the door. Okay. So now I have a towel rack. The bar is fine. One of the hinges is fine, one of the things that attaches it, but the other one's all stripped out. Nothing's wrong with the door, nothing's wrong with the rack, except for this one mounting bracket thing for it. Well, so my house was built in 2000, and it's the same shower door since then, and it was some kind of custom fit thing then. What are my chances of getting that same bracket? Not good, right? Not good. Could I possibly find a different kind of bracket that would fit the current door? Probably. Yeah, you could probably find something. You want to be a little careful at my skill level of drilling through the glass and stuff like that. So you have to think about, you know, do you just Gorilla Glue this thing on there or whatever? You might have options, but those are $30, $40 options, whatever, to try. Well, what did I do? The two brackets were equivalent to each other. Just one of them was flipped over the other way. So I brought it in. Now I could have tried to do this myself, okay, but Blade, the guy who runs our makerspace, is pretty skilled at this stuff now. So I brought in this bracket. I said, I need a new one. Okay, so it took him, I don't know, probably a half hour. Just did a quick scan of the thing, you know, cleaned it up, mirrored it to make it the other side. 50 cents in plastic later, probably less than that. You know, but I'm removing his labor time or whatever, but still way cheaper than, you know, I had a new bracket. You know, now we can have a business, right? Selling custom one-off brackets that you can't get anyplace else. Reinstalled it in my shower, works fine. Haven't had a problem since. You know, but so that's kind of a good example of using a tool for kind of what it was meant to. But when we talk about VR, you know, VR started in the high-end wired realm with PC gamers. It became more mainstream through mobile VR devices, which allowed you to use your phone as the let's say the guts. This was not a good end user experience, but it allowed everyone, i.e. the number of people who had smartphones, let's say, to try VR and get an idea of the potential. Then we had VR specific mobile devices. We're going to say mostly made by Oculus, which is owned by Facebook. So this started off as the Oculus Gear was the first one, which was a VR headset uniquely designed for the Samsung Galaxy smartphones and was running its own special OS that was easy to use in VR, which was a big deal. Because think about before that, you can go out and get one of these cheap headsets, right? That you can strap your cell phone onto. You can even make them out of cardboard. Remember Google Cardboard? You can get these, cardboard-based ones, and the whole purpose of these things was to strap your phone to your eyeballs, right? And then inside it just had the two lenses that that were there, and you did your thing. But the way it worked is you had to open up the app first, right? Then you just strap the thing to your face, okay? Wiping off any smudges you put on there. You got it on. The thing's not comfortable. It's hurting your nose and things like that, and then you can use it, but you didn't really have any hand controls or anything. So you had this little magnetic thing over here that you can pull down, and it kind of lets you move through the app and stuff like that. So again, the end user experience was not great, but it was evolving, right? Gave you an idea. Well, so what did Oculus Gear really create for us? Well, it created a better, a more comfortable headset, first of all, something that felt premium. Cost was premium too. It was like $130 just for this headset. That was on top of the $600 plus phone you had to have that was compatible with it. That would overheat, first of all. So now you have that, but the killer app for this was the Oculus OS, which ran on it. So now you had a little remote control. Okay, it didn't give you the two wands, it didn't give you the thing, two different hands you can sit there and swing swords with and stuff like that, but you got one little controller. Okay, and that controller allowed you to point and click. It was kind of your virtual reality mouse, so to speak. And now you could use this operating system in VR, switch between apps. You had an app store, all that stuff, and enjoy VR at a much higher level until it shut off because your phone got too hot. So then you had people create these contraptions of like fans and stuff like that, or they would do all their VR. Like when I was using the Oculus Gear, I would, at my house, first of all, on the back of my phone, I got a case that fit my phone that also fit in the gear. Then I got a whole bunch of heat sinks and glued them to the back of this case to distribute heat away from the device. Then I would sit in a chair that allowed me to swivel around, because I think some of the killer apps for VR are like travel applications. And I mean, you can go on a tour of London in VR and save yourself a plane ticket. Okay. Now I've traveled the world with my wife and stuff, and so I'm not telling you don't do that, but I've been to a lot of places, and I've been to some of those same places in VR, and it's kind of nice sleeping in your own bed that night. So it doesn't replace all of the experiences, but it's better than it should be by a lot. Okay. So definitely worth trying. But now the idea is so I had the swivel chair and I would sit there, but I had fans. I had four of those like rotating fans all around me, so it didn't matter which direction I was facing. It was constantly blowing on me to get the heat away from the device, right? Because the device driving the Oculus Gear would get too hot, and then it would say you need to turn your device off for so long, it's got overheated, whatever. All right, so a lot of extra work to get what was supposed to be mobile VR, but not that mobile because you have to have external wind in order to keep going. Well, from there, they then came out with the Oculus Go. What was the Oculus Go? The Oculus Go was Gear VR plus a high-end, we'll just say, phone built in, all for $200. Same operating system that Gear VR had, same setup, except you didn't have to plug your phone into it. And it still got hot, but it had better heat dissipation things and ran off of its own battery. Okay, and you charged it just like it was a cell phone. You plug it in on the side and it charged up. All right, so this was the Gear VR standalone, didn't have to use your cell phone for it, which then opened it up to people other than Samsung Galaxy smartphone users. Okay, big deal. All right, then you have the Oculus Quest. So this brought in, so this was 6 degrees of freedom, dual hand controls, could mostly run anything from the go, and also had apps specifically made for the Quest and several Oculus Rift apps, which was their PC VR headset. These guys were ported over. So many of the popular Oculus Quest or Oculus Rift apps for the PC would now run on the Oculus Quest natively, with some of the graphics kind of turned down, something like that. But now you have much closer to the full PC VR experience, where you got the 2-hand controls and you're diving around the room, and 6 degrees of freedom means that you can, turn your head all the different directions, your hands go in all the different directions. You could also move forward and back. So you have, kind of a play space around you that you can move around in that play space. The Quest uses what's called inside out tracking, which allows you to, it sees your environment around you, and you just draw kind of a circle where you decided it's safe to travel while I have this headset on, and it does all the work for you. It made the setup easy. We're setting up a PC VR. Once you got it set up, it was great, but it was a hassle, right? So this idea of moving PC quality VR over to mobile was a big deal. That untethered us from our computer, and we got most of the performance, just like we've seen with our laptops over the years, right? We're no longer tethered to our desktop computing or computer. What are we trading off? Probably like monitor size, a little bit, maybe some horsepower, but not even so much that anymore, right? You can get laptops, as long as you're willing to pay for it, that have almost all the horsepower that your desktop has. And now it's not even that much of a premium, right? If you were going to get a gaming laptop versus a gaming PC, in many cases, you might even be able to get the same GPUs in them. So all you're really cutting out is the very highest end of PC gaming and a big monitor, right? When I say big monitor, there's plenty of PC VR or laptop VR laptop gaming machines that have 17-inch monitors. So kind of the go-to move for a desktop gaming thing is about a 24-inch monitor with 240 hertz refresh. So you're not giving up that much, is the punchline. So as we kind of go down this path with VR and going to more mobile VR, we're making it more mainstream. So now we have mobile VR. Lower graphics, but untethered to a computer. Has access to a large library of applications, but it did not have all of them, and the applications written for mobile VR were written for ARM architecture. So remember, the catalyst for this was the Samsung Galaxy, which was running the Snapdragon processors, which we've talked about are ARM processors. So those games were written, compiled, yada, 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 for specifically those devices. So the Intel-based games for the PC would not run natively on the Quest. So what happened next? Oculus released the link cable and software that allowed you to run, well, it allowed you to use the Quest as a PC VR headset. This did not allow you to run PC VR stuff wirelessly on the Quest, but it did allow you to use, the Quest to access, use the Quest as just a headset to play PC VR games as if it was any other PC specific VR headset. Big deal. VR is expensive. I can go out and for $400, I can buy one device and it gives me mobile VR and it gives me PC VR. Pretty good PC VR. Killer application. Hate Facebook all you want, okay? They own VR, okay? Any way you cut it, they own VR. All right, so now you have this. To make it even cooler, there is an application on Quest. I'm going to say, as well as all VR ecosystems, called Virtual PC, which allows you to control your normal PC from within VR. Now, at first, you might say, well, this sounds awesome. I can be in VR and I can create multiple virtual desktops and I can, use the ARM wands and stuff to double click on icons. And, I tell you what, you're not going to go into VR and open up Microsoft Word and write a paper. Okay, first of all, even if you're a touch typist, a lot of you glance at the keyboard, right? Make sure everything's centered and you can't see your keyboard in VR. Okay, and you're certainly not going, and that's going to be the next killer app, and they're already starting to move in that direction. But once you can bring, we think of the keyboard and mouse as being boring, but they're also the best tool for the job for many jobs. And we don't have those in VR unless you're kind of fumbling around for it. But we're getting close to where that will become a VR thing, where your hands and your keyboard are kind of shown to you while you're in VR, and you can sit there and click and stuff. Okay. So there's this application called Virtual PC, which allows you to control your normal PC from within VR. So what? This is neat for a few minutes until you decide it really isn't practical. virtual PC for VR. Had one special feature that allowed you to bring some of the content from your PC into VR in a more convenient way that could easily be launched from within VR. All right, so a lot of 3D, 360-degree videos, things like that. The best way to digest them was by running them off your PC, because you didn't necessarily have an app that was supportive of it. Like YouTube VR, for example, isn't that great, has gotten better, but the best way to get 360 content is using your PC browser, but then you don't want to, you can use your laptop and turn around and stuff like that to see the stuff. You can use your cell phone, turn around to see the stuff, but that's not the point of VR, right? The point of VR is that you're sitting there and you're immersed in the world because you have this headset on. Well, now you can launch these 360 videos using virtual PC, and it brings you into that virtual environment. That's really cool. Things like 360-degree movies and travel things, etc. Okay. The other thing, it also allowed you to launch games from within VR, presumably to play those PC games using your VR headset. Let's say play those PC games on a giant screen using your VR headset. One of the killer apps for VR, I would have said, is something like you could watch Netflix on a 100-foot screen in a broom closet. You don't need the space, because with a VR headset on, it can create perspective, as if you're sitting in a movie theater, you're looking up and you have your Netflix show playing on a movie screen. Same thing's true here. You're playing your video game. You got your PC controller, whatever. So for your games, Counter-Strike, whatever your game of choice is. And now you can launch it and you can play it on a 100-foot screen inside of VR. And as long as you still use your controller without having to look down at it, you can play that game on the giant screen. Some people would like this, some people don't. We already mentioned a little bit earlier today that if you're a diehard PC gamer, there is a kind of a ideal screen size that's right around 24 inches. Larger than that is cool. It's got the shock effect, but doesn't necessarily increase your skill or performance. In fact, there's a point where it makes things worse. All right, kind of like if you sit in the front row at a movie theater with a really giant screen where you can't see all of it in so then you're like physically having to turn your body to take in the whole movie. Same thing like that for the games, but still cool to say, hey, I'm gonna pick your favorite PC game, Counter-Strike. I'm going to play it on a movie theater screen, and it's just going to be fun. Okay, that type of thing. So this allowed you to launch games from within VR, presumably to play those PC games on a giant screen using your VR headset. With this in mind, Oculus Quest could wirelessly launch a video game using virtual PC, and that game could be a VR game that then gets wirelessly streamed to the Quest, so you can play PC-based VR on the Quest. Wirelessly. Big deal. So now you have a wireless version of PC VR and a wireless version of mobile VR. It's pretty good. So what do we have now? Across the hall, we have this really cool VR chair that is set up with an Oculus Quest that's capable of playing just Quest games. And you put this attachment thing on the headset, so when you turn your head and stuff, the chair moves with you. But it's also capable of playing PC VR games wirelessly from a PC that we have sitting near it in proximity. But the whole chair experience is a completely wireless experience. That makes sense? The only thing you're at the mercy of is battery life of the VR headset, right? But nothing keeps us from creating, getting some of those battery packs and attaching it to the back of this chair and running one wire up that puts it in there. And you could probably even power that thing from maybe the chair or from an outlet nearby. You do have to think about the wire getting wrapped around or something. But bottom line is you could probably get many hours of battery life on your wireless VR playing both PC and mobile VR in a fully immersive chair. This exists today right across the hall from where we are today. That's pretty cool, isn't it? Okay, so now we ultimately have great wireless VR. Oculus releases the Quest 2, which is faster, cheaper, and higher resolution. Big deal. Better device, less expensive device. Available for more people now, right? Even people who just want to do mobile VR. So mobile VR is still good. In fact, I'd still say mobile VR is just about as good as PC VR, because PC VR is still where a majority of the games live. So if you're interested in PC VR games, then it opens up a world to you with this single headset. But if you're really interested in what I believe is the killer applications of VR, travel, virtual meetings, things like that. Some of you have been on Zoom meetings with me when I've gone into VR with it, and you see me, I can write on a whiteboard. I'm like this wizard in VR. You see my avatar. Cool things like that, you can say, well, I'm not sure how practical that is yet, but it's that proof of concept that this is a direction we're going. And now there's companies working on effectively creating office buildings completely in VR, where especially now with remote workers and COVID, right? We're sitting at home, you go to work in the morning, no problem. As soon as we can get your productivity tools into VR, keyboard, mouse, that kind of stuff, you sit down at wherever, you put your headset on, you are at work. You got to go talk to Sally in her office. You travel through the building, you go up the stairs, whatever, you knock on Sally's door, you can go in, it creates maybe a private room where you can talk to just Sally and you're having a private conversation, whatever. All this exists without the real estate cost, the electricity cost of powering that building, all that stuff. You don't have the heat, the air conditioning. That's kind of amazing, isn't it? This is here today. And now we have an excuse to use it with COVID. And we're getting close to being able to now with these relatively inexpensive wireless headsets. This is like amazing stuff, isn't it? So what comes next? Kind of the sky's the limit, isn't it? But it looks pretty good for Facebook. Again, love them or hate them, right? You know, these social media platforms are all under fire, you know, with all the politics stuff. Depends on which side you're on, or, you know, or somewhere in the middle. We just all wanted to be over, you know, but the social media are getting, you know, under heat for censoring people, right? And some people think those people needed to be censored. Some people say, well, even if they needed to be, they shouldn't have been, right? That's how the platform works. I'm not sure I have a strong opinion either way. I could probably argue either way, but bottom line is that Facebook's got a pretty good alternate business model going on, where I'm not sure Twitter and some of these other ones do. So take it for what it's worth there. All right, so that's our virtual PC stuff for VR, and really how we've taken this mobile platform. How we've created a mobile platform of something that was strictly expensive desktop platform, effectively seeing history repeat itself like we did from the PC, but now we're seeing it do it in VR. And now the cost has come down to the point that people who are aware of it can take advantage of it. Galib,
No.
lights went out. All right, we're back. And remember, one of the things that I brought up in one of our earlier classes was, as technology specialists, that's what we all should be, right? As technology specialists, we should have the ability to be able to go into Best Buy and not get taken advantage of, right? So I'm going to presume, at least for many of you out there today, you weren't even aware this stuff existed and how far the rabbit hole goes with this. That make sense? So you would get taken advantage of at Best Buy. It's a problem. All right. So do I want to start this next? This is off script, but we're going to do it anyways. Okay, so research the differences between the original Oculus Quest and the Oculus Quest 2. Kind of talked about that today, just so you can see the hardware differences between them, as well as the other mobile VR options available, which we did not talk about today, but I'm telling you they do exist. And write a 3-page paper comparing and contrasting all of these things. What do the non-Oculus platforms need to do to catch up to Oculus in this mobile space? So today we talked about how great Oculus is, right? You know, and punchline is you're probably going to find Oculus is currently the winner, right? So my question is, as you look into this, is who are the other players and what do you think they're going to need to do to catch up? Make sense? All right, questions, comments, concerns, bribes. All right, I'll see everybody on Wednesday. I won't start the next slide because it's completely unrelated to what we talked about today.